Today is September 5th. Every day. All right, 9. Okay, so today we are looking at the relationship between exponents and roots. So it turns out, let me just see how I started here. It turns out that square roots, like the square root of 20, oh, look at that. The square root of 25 has another form that we can write it in. That means the same thing. And it turns out they're called rational exponents. Rational fractional exponents. So when I look at the square root of 25, what's the index in the little elbow here? 2. Very good. And it turns out that 25 actually has its own little power on it. Everything always has a power of 1, right? Mm-hmm. And so the square root of 25 can also be written as 25 to the 1/2 power. What? I know, it's totally crazy. But it's kind of neat. And means the same thing. And so when you see 25 to the 1/2, you think to yourself, that's just the square root of 25. And what's the square root of 25? 1. Okay. All right. And so if I had the cube root of 27, then that's the same as 27 to what power? 1/3 power. Okay. Yeah. Very good. That's kind of cool, right? Yeah. It's kind of crazy. Well, later on, we'll be solving equations and stuff like that, where this is really, really useful. And in higher math and calculus, we never like to see radicals. Everything we do, we use exponents because life becomes so much easier. So, so this is kind of a useful thing. Jacob. How would I add them? What do you mean? That's a good question. So, you can add like radicands. So they'd have to, like this simplifies to a number. So, yeah. So, but you can still combine them and simplify them and clean them up like we have with radicals. So we'll learn how to do all that. But that was just letting you know that radicals can be written with rational exponents. So let's practice a few. All right, evaluate. Now, first of all, I would like you to notice that all of these are just numbers. Can you use your calculator? Yeah, absolutely. There's no letters on this page. Every single one of these can be evaluated using a calculator. Okay, so this is notation. Good question. So this is rules. So I have a base, b for base, raised to the m over n power. And if you see something with a fractional exponent, then what we can do is it's equivalent to rewrite it either this way or this way, where, like we said, 1/2 was the same as a square root. So whatever that denominator is, the n goes in the index, and the m is the power on the base. I like to think about it as this sort of thing gets, this little bar swings around and then gets caught up in the radical. Okay, do you see it? It's like an arm and it swings around and it gets swung up and caught inside the elbow of the radical. You see that? No, you don't see me like taking that in and then swinging it around and getting it caught in my elbow? You got to envision my arm on a hinge to do that, okay? So both of these are equivalent. That's what the equal sign means. And sometimes we like to take roots first. and then we'll evaluate the power. Only because when we take a square root or a cube root or fourth root, numbers get a lot smaller. And then we can raise them to whatever power we have. So what we're going to do is basically just practice going back and forth here. 25 to the 1/2. This is the power, and the 2 is the index. I like to think PI just because I grew up in the 80s, so Magnum PI was like a really popular show. Tom Selleck and his short shorts. Holy mackerel. Okay, so so I like to think power over index, PI, and so I can rewrite this as a root. What's the index? 2, and then we have 25 to the first power. So I could write it this way, which is sort of how this is. Or I could write it, or I could do it this way where my power of 1 is on the last thing I do. Either way, I know that the square root of 25 is 5. And 5 to the first power is just 5. Okay. Lots of ways to write this. It just takes a while to get used to it. 16 to the 1/4 can be rewritten as the fourth root of 16 to the first power. What is the fourth root of 16? 2. Why? 2 times 2 times 2 times 2 is 16, and we're looking for a group of 4. 1 escapes, and 3 get shot. Oh. Yeah, your odds of getting out of jail is terrible the higher the root. The fourth root of 16 is 2.
Oh, wait, it's a...
Oh, here's a really cool thing. I just thought about this. Just watch. 16 can be rewritten as 2 to what power? 2 to the 4th, yeah. 16 was to the 1/4 power. This is why rational exponents are cool. What do you do when you have a power raised to a power? You multiply them. And what is 4 times 1/4? 1. So it equals 2 to the first, or just 2. Wow. That's kind of cool. It's a really, rational exponents are super cool. All right, so let's look at this one. Again, I'm going to go ahead and rewrite negative 27 to the 1/3 power as a radical is what? The index is 3, and we have negative 27 on the inside. That's our base. And again, it's to a power of 1. What is the cube root of negative 27? Negative 3. That's it. That's it. So you already know how to do this. This is just notation. This is a little different. But it rewrites exactly the same way. So what's the index? 3, yeah. Power over index, PI. So this is a cube root of 27 to a power of 2. All right. So we're going to evaluate inside the parentheses first. What's the cube root of 27? 3. To the second power? 9. Okay. 9. All right. Ooh, negative exponent. What does a negative exponent do? Yeah, it creates a fraction. So I'm going to start by rewriting this as 1 over 32 to the happy 2/5 power. Negative exponents create fractions. All right, now let's rewrite our rational exponent here. What's the index? 5. So this is the 5th root of 32 to a power of 2. What is the 5th root of 32?
2.
2. Because 2 to the 5th equals 32. Okay. All right, so this is 1 over the 5th root of 32 is 2, and we still have a raised to a power of 2, so that's going to be 1/4. What's the difference between C and F? One's in parentheses and one is not. Okay, what does this power affect? Everything in the parentheses. What does this power affect? Just the 8. Okay, so this 4/3 is only affecting the 8, so the negative is sort of just chilling out in front. And so we have power over index. So this is a cube root of 8, and it's being raised to a power of 4 with a negative way out in front. What is the cube root of 8? 2 to the 4th. So now we do our exponent. What is 2 to the 4th? 16. And there's still a negative out in front. In case you were curious, all of these can be done on your calculators. So something like 32 to the negative 2/5. In the Casio here, a little more complicated. 32, this button is called a caret. Oh, you can't really see that too good. It's the little, I don't know, I call it a caret. Insert, I don't know what it is. What does it look like? Just this little pointy arrow thingy. Kind of, okay? And then I'm going to put this entire, like, 2/5 in parentheses. So negative 2 over 5. So that says 32 raised to the power of negative 2 divided by 5. So negative 2/5. And I get 0.25, which is a decimal. But I can turn that to a fraction. The FD button is fraction to decimal. 1 over 4. 1 over 4. Okay. Alrighty, so all of those can be done in your calculators. No problem. Okay, questions on those? Example 2. This is it. Now these look really complicated, but actually you already know how to do this too.
We do?
Oh, you do. It's just properties of exponents. Same thing. So you already know how to do stuff like this. Like x cubed times x to the 5th is? Hey, guess what? It works the same even when they're fractional.
Really?
Totally. So you already know how to do this. So perform the indicated operations and simplify. We just want to make sure that our final answers use positive exponents only. And I should also tell you on these first problems, we don't have to worry about rationalizing. Because remember, rational exponents are radicals, but they're not going to make you rationalize right now. So just like when we have the same base, we're allowed to add the exponents over a product. Okay. So again, we have a product. They have the same base, so what are we allowed to do? Add the exponents. But how do you add fractions? Yeah, old joke, calculator. You can use a calculator, but yes, you need a common denominator. You didn't find my joke funny? Okay. 1/2 plus 2/3. What's the common denominator? 6. So that would be 3/6 plus 4/6, which would give me x to the 7/6. That's it. I'm pretty sure that's all we're doing today. I better check though. There is something you can do, but I don't recall. I don't recall exactly how far they want you to go.
If not, are we going to get to
That's good. No, this is it. We don't have a value, so I can't like get a number insert. Does that make sense? I don't know what X
but
is.
like, if are we going to get to the end, if there is a number,
Yeah, we'll do that tomorrow. All right. If you have x squared raised to a power of 5, so you have a power raised to a power, what do you do to those exponents? You multiply, you'd get x to the 10th. Same thing here. We have a power raised to a power. So what do we do to the exponents? Multiply. The base stays the same, and we're going to do 2/3 times 3/2, which is a to the first. 6/6, which is just a to the first, or a. Okay. All right, letter C. We have 16 times y to the negative 2/3. What do we need to do with raised to the power of 1/2? Multiply. Yep, it's power raised to power. 16 has its own power, doesn't it? Yeah, so it's important to remember that we need to share that. We need to multiply all the powers by the 1/2. So this would be 16 to the 1/2 times y to the negative 2/3 times 1/2, which would be what? Negative 2/6, and negative 2/6 reduces to negative 1/3. Good. And what is 16 to the 1/2? 4. Yeah, isn't it the square root of 16, which is 4? So if it's just numbers, they want you to go ahead and evaluate, work it out. Okay. And one more thing to do here. I need positive exponents only. So what is this little negative going to do? Yeah. So what goes to the bottom? The y to the, yeah, that goes to the bottom. The 4 is perfectly fine where he's at, right? In fact, he's got its own little exponent of 1. So perfectly happy x 4 to the first. So 4 is going to stay on top. And then y to the 1/3 goes underneath. And we can leave it just like that today. Yeah. Okay. In a division problem, multiplication, what do we do to the exponents? Add. What do we do in division problem? Subtract. The base stays the same, and we subtract the exponents top minus the bottom. 3/4 minus the negative 1/2. So what do we need to do in order to combine that exponent there? Common denominator. So that's going to be, let's see, 6/8. Oh, it could be 4. Oh, thank you. You guys are so smart. 3/4 plus, why plus? Yeah, minus the negative is positive. 3/4 plus 2/4 is y to the 5/4. So the rule of thumb is that if it starts with rational exponents, then it can end with rational exponents. So you don't need to rewrite it with a radical. Okay. All right, here. Can I subtract these exponents?
No.
Why not? Yeah, they don't have the same base. Very good. So instead, what do we do here with the 6? Yeah, multiply it in. It wants to go to all those exponents. So that's going to be x to The third, yeah. 1/2 times 6 is 3, and y to the second. Yep. 1/2 times 6, and 1/3 times 6. That's it. Any questions? That's it. Yeah. All right. Take your time.
When do we have the next test?
It's 2 weeks. I don't know. Yeah. I think it's on the 16th. Is your next test. All right, ladies and gentlemen, homework.